Hey, welcome everybody to a bonus live stream. Just wanted to actually kind of get started a little bit earlier. I am going to start actually answering some questions in the next 3 minutes. However, if you are kind of joining in, I did want to just kind of let you know what we're going through, but I just decided, you know what, I got everything set up, so might as well get my live stream kind of getting started, and therefore I can also fill up maybe some questions, because usually a lot of times when I do my live stream, those first couple minutes, people kind of hop on, they have those questions and stuff. So I am going to start at 9 o'clock. That's the time that I said I was going to officially start, but I am just thought I would get the live stream going a little early. So if this is your first time on this live stream, this is a bonus live stream. I usually do not go live here on Wednesday nights, as obviously it's a school night and we got different things going on, but I know that with exam kind of time coming up, my students are not actually taking their exams until next week. I know some of you have already taken your exams, but maybe you guys have some other quizzes or tests and stuff, as you're rounding out your semester, or maybe you're done and you're just enjoying yourself at this point. But either way, I just wanted to kind of do just one more extra live stream, just in case maybe I can catch a couple more of you that maybe have some questions that you are just looking into as you get into these maybe final tests and quizzes that are final tests and exams that are coming up. So at least in this live stream, I'm going to start it with just when given a root, go ahead and find the remaining roots using synthetic division. We're going to go ahead and solve a systems of equations. Solve an equation when we have different exponents and different bases. Then we're going to practice condensing some logarithms. I will talk about bearings and how to kind of sketch them. And then evaluate using the sum formula for tangent of that angle. So if I'm hoping that, based on my timing, I might be able to add in a couple more questions for those of you. And obviously, again, the questions that most people try to add in on this, they will, I'll try to get to them as best I can, guys. And we're almost coming into that 9 o'clock time frame. So I'll try to get to your questions as best I can. But obviously, it's always great, guys, if you are obviously subscribed and have that notification bell. So therefore, when I do put a community post, as far as letting you know when my live stream is, then you can go ahead and get your questions prepared and submit them, because I do look at all the community posts, or at least the comments that are on my community posts before I do my live stream, and that's where I generate these questions. So some students would do the Facebook, and which you can still do it, but I think I got most interaction from those community posts. So, the only thing is, when you are submitting questions, just make sure you either give me some details that you want me to do, or provide me actually a problem to, explain off of, or to actually solve and use, because otherwise I'm just making guesses. Just to fill it up, I kind of, I made up that problem, that one was given, I made up this problem was given to me, and I made up that problem. So I really don't like making up problems. There was a couple other requests I had for as far as me to do something, hey, do this type of problem. I'm like, well, I don't have a textbook in front of me, nor do I really know what the type of problem that would best suit you. So, always being specific on your requests and questions. And again, I can't get to everything, guys. I mean, it's, obviously I've been a teacher for a while, so a lot of the upper level mathematics, it's just been so long since I've really gotten to them. So I want to make sure that I am covering at least the math that I feel comfortable and confident explaining, because I want to make sure whatever explanations I'm providing is going to be something beneficial and going to be worth your time. I don't want to be stumbling over and then need to take 15 minutes of thinking through a problem on a live stream. It's kind of awkward that way. At least it's awkward for me. So, all right. Well, good. I see 9 o'clock. You guys have made it on there. So, very welcome, Rohan, just for you. Malin, Jaden, good to see you guys. Anna, thank you. And Christian and Layla and Tony. Wow. There's a lot of you guys on here. All right. Very good. So, now you're told, I'm missing some things. All right. Just for you. I see you got it. I got it. Don't worry. Please do not start spamming, because I really do not want to block you from the comments, because we don't need people to be adding in things. I will do this, but please, I do not want to set this precedent. Just the more that you type, then that means the more that you're going to get. So please do not write in your question more than a couple times in a certain thread. All right. Let's see here. 50 invoice. Good job, Rowan. Gabriel Coleman. I'm in 8th grade. That's awesome. Look and find your page. Subscribe. Well, thank you very much. I appreciate it. Keep on working hard. And Louis says, I'm stuck on my review. Can you help me? Well, I mean, I can try to do my best. If you have some questions, I'm not going to work through the review because I have my own review and exams and stuff I got to do. But if you have any specific questions, you can sure put them in there. You're very welcome, Chris. Hi, Emily. Just for you. I got you. On a pre-click was a breeze. All right. Yeah, that's mostly a lot of it in there. Geez, just for you. You got a lot of questions. I'll get to your question here. All right. How do you graph functions? Pamela Pamster says, I'm not sure what type of functions you are graphing. I'm going to do a function right now, the cosine function. But if you have something else, I'll be more than happy to do it. Alison Aguirre says, how do you graph tangent and cotangent? You know what? Let's just do the same thing. Why don't I add on to his, and I'll do y equals 2 cotangent. Let's do cotangent. Cotangent of 3 theta. So we'll just kind of do a cosine and a cotangent. Just kind of do a comparison. Add on to that. So hopefully that kind of helps out there. Logarithm with this. Run a scenario. It plain flies it. Yeah, I'm not going to be able to find the bearing run, but I can definitely go ahead and help you at least get that one started because I don't have a calculator, so I'm not going to be able to do that. But if you're at, so you have a question, so I'll do mine over here. So yours is north, where that goes, north 20 east for 300 miles. And then north 40 degrees east for 150 miles. And then the question is, if I find the bearing from start to end. Oh, okay. Gotcha. So you got to find the bearing. Okay, so I'm not sure if you left the question on bearings, but somebody literally just said bearings on the community post. So I had no idea what to really cover. So this is nice. I can cover this and explain that because it's a little bit differently than what I was thinking. What is cot? It is cotangent. It is the cotangent function, which can be represented as the ratio from the adjacent side to the opposite side of a right triangle. Trying to go through and check this. All right. Cosine, cos stands for cosine. 3 log base 2 plus 1 divided by 2 log base 4. Jaden, I'm not sure what log base 2 plus 1. I'm not sure what your question is or what you want me to do with that. So please go ahead and use parentheses on your question. So therefore I understand what is what. You can just, because I'm not sure, 2 plus 1 divided by 2 log base 2 raised to the 4. What's raised to the 4? That's what I'm not sure, Jada, on your question. So if you could maybe use parentheses in that, that'd be a little bit easier. How can you calculate tan of a plus b? Well, I'm already going to do, yeah, we have a plus b. So we're going to go, I'm going to do a problem like that. It's been way too long since I've done anything with matrices. So sorry, Mohammed, I'm just not going to be able to get to, as far as at least explaining the matrices. It's just been like way too long since I haven't taught it ever since I've been a teacher, and it hasn't been since my undergrad that I was doing matrices. So my explanations would not be on point. So unfortunately, I'm just not going to get to them. How do you know where to shade a linear? Soccer girl asks, how do you know to shade a linear inequality? Use a test point. Plug in a point, any random point that's on the unit circle or that's on the graph that is not on the line. And then if that point makes the inequality true, then that is the side of the angle or the side of the line that you're going to shade. So use a test point. And I can talk about that. We got a little time. Let's do that because that's a big question. Test points. So let's just do a basic one. Y is less than or equal to, or let's just do y is less than, let's do, I don't know, 1/2 x minus 1. We'll do something like that. Or let's just do graph. I'll just do a basic problem. But test points comes up a lot with a lot of students. No, what am I doing? I want to graph. All right. -2 tan of x minus 1. You don't like my one. Allison, you're the one that asked it earlier. How to graph tangent. Because now you're going to make me... I don't know if you asked earlier. All right, well, I can go and do this. I want to get started because I know some people have some questions and people have added on. Yes, Ron, that's good. Cosecant, secant, -1√2. I'm not sure what the question is. Go, sir. We're getting to that. I'll graph -2 tangent y equals x really quickly. I'm not going to spend too much time on this since I'll already do a problem. Y equals -2 tangent of x, and I'm assuming that's a -1 on the outside. All right. I'm not sure, Lauren, what you're exactly looking to go ahead and complete with that. If you're looking to expand, maybe, Lauren, I guess. I'm not really sure. I'm starting to get a lot of questions, and I'm starting to freak out because this is what happened back in the day when I used to go ahead and do these. I'd do them, and then I would just get so many questions, and I'd have to cut it off. But Lauren's question looks interesting, so I'm going to believe this is a ln of e to the -1 divided by e plus 1. Nothing like I've done before, so I'm hoping this is nothing raised to the 2/3. So I'm just going to expand this, and hopefully that's what you Hopefully that's what you were looking for. All right. Hey, I'm taking AP because is it possible for you to help me with some of the problems regarding logistic growth model? No, I probably won't be able to just because it's been 2 years since I was teaching calculus, so I just would not be on point as far as my explanations to be able to get onto the help. So I do apologize, but that's unfortunately I want to get back into calculus, so therefore my explanations are much quicker. But right now I would just need to like review too much of the material. It'd take too long for me to give you a good explanation. I'm not really sure, Magic, what you want as far as exponential equations, how to find holes. Yes, I can cover that. I'll do the shading. What grade level of math is this? I have no idea. There's math all over the place. I'm not sure just for you what that means. Cube roots, please, Grace. I'm not sure what you want for cube roots. There's a lot of different ways I could go with that. All right, Jaden is coming back in there. So 3 log base 2 times 2 plus sign 1/2 log base 2 times 4. But I don't understand log base 2 and then times 2 plus sign 1/2. I'm assuming you're trying. I mean, this is the way that I'm gonna write this. I don't even know if this is it, and you can maybe tell me, explain, Jaden, what's a little bit best. I'm not sure the times 2 because it's not times 2, it's of 2. So I believe that's just your understanding. It's not times 2, it's of 2 plus 1/2 log base 2. It's of. The argument is 4. It's not actually being times. It's the argument of, but it's okay. I believe that's it. So just give me a nice little thumbs up if that is it. Find the exact value of cosecant, secant, inverse. Oh, okay. All right, guys. All right, we are going to get started. I'm going to keep on going through this chat, and I will keep on adding in some questions until I at least get up to 15, either 15 questions or 9:15. But that's going to be it. So I'll go ahead and do holes. Yes, I'll do that as well. So we have cosecant of secant inverse of √2. That's a good problem. Oh, well, I'm not going to be able to figure out. Oh, yeah, I can figure out the cosine. Okay. So we got that one. 12, I'm going to do wholes and roots, or just do wholes from a rational equation. So let's make something up here. Let's do x squared minus 4 over. What question is that? Not at 3. That's 13. I'll do 2 more questions that I want to add in. Then we're going to get into this math. So x squared, let's do, I don't know, plus 3x plus 2. All right, so I got room for 2 more questions, guys. And then unfortunately, I am sorry, I am just gonna have to end off because then I got to get through my explanations and I want to at least try to go to bed tonight. You know, I still got to teach tomorrow. And I know some of you are maybe even waiting up for a question. So you're going to be like, I need this answer before I go to bed, or so I can study. All right. So I do apologize. I know there's way too much chat that I can get into. Get to there. Polynomials. Thank you. Factoring polynomials. All right. You got the super chat. So you win over. I would really love, though, if you gave me a little bit more of depth questions, because I don't know what kind of polynomials. Do you want quadratics? Do you want polynomials to the third power or third degree? Do you want polynomials to the fourth degree? Do you want trinomials when a is not equal to 1? Do you want factoring by grouping? So I mean, since you're giving a super chat, I would love to give you something more detailed, but I will add in factoring polynomials and I will wait for your response. Otherwise, I will pick something. But please, guys, do not get any more super chats, because I'm going to feel really bad if I cannot honor everybody's question in here, because just for you, I'm not sure as far as graph the sign, the EOA, I don't know what that is. And the period would the amplitude is 2. So you just make sure you put the 2 out in front, and the period equals 60. So 2 pi divided by b equals 60. So then it'd be pi over 30 would be your b. Kind of an odd question. I'm not sure what EOA is and for the graph is. All right. Shayla, I'm not even going to touch word problems. I am sorry for for typing all that, but we don't have time for me to get to all that. Yes, I do have a couple log problems up there. Let a equals x, solve for the quadratic. I'm not sure how I'm supposed to solve for that quadratic. How do you find the x-coordinate point of inflection for a function f on the graph of the first derivative? I'm just not going to be able to get to it. I don't want to cover any of the calculus portion, just because I want to make sure that my explanations are going to be on point. And it's just been a while since I've had to explain any calculus topics. But one thing, obviously, when it says find the first derivative, find the derivative of the function. And then obviously you can look into, go ahead and find the derivative and then understand where the inflection point is. How is that related to your derivative of your function? And it might be easier to kind of look at polynomials first of all. All right. Well, I do have one for factoring. So hopefully polynomials algebra, you want to do this one. I like this one. So how do you find the zeros of x to the 4th minus 5x squared minus 36? That's a good one. I'll take that one. I like that one. Final examiner, describe the right hand and left hand behavior of the graph. This will be easy enough, so I'll add this one. All right, guys, I think that's going to have to be it. Let me see how fast I can do these. I don't want to spend too much time on these. So I'm going to try to do this as quickly as I can, and then if I do have some time, I'll get to it. Unless polynomials algebra, do you add in any other functions? You did not. Do you have any study guides for honors algebra 2 exam? No, I do not. So you can stop typing that. I apologize, but I do not have any exams for you. So sorry, I only have my pre-calculus exam, which was on my video like last week. If you want to look at that video, that pre-calculus exam basically covers polynomials, functions, a lot of algebra 2 topics. And so therefore, hopefully that should be able to help you out. Probably maybe, but it's not designed for algebra 2. It's designed for pre-calculus, but it's all algebra 2 topics. All right, guys, I need to get going with questions because I have 15. That is awesome. But now I need to start doing some math. So my time is up. So For those of you guys joining in here, we got a lot. We're going to do some roots. We're going to do solve it as system, solving an exponential. We are going to condense. We are going to talk about bearings. We're going to do the sum formula or sum identity. We are going to graph trigonometric functions. We are going to graph a linear inequality. We're going to graph another trigonometric function. We are going to expand a logarithm. We are going to evaluate a logarithm. And then we are going to evaluate the inverse of a trigonometric functions and their inverse. We are going to find the holes and asymptotes. We are going to factor a polynomial, and then we are going to find the left and right hand behavior. All right, guys, I am not going to get to any more questions, so I do apologize, but no sense in really adding more to this mix. I'm just not going to be able to get to them. If for whatever reason I am feeling very spunky at the end of this live stream, then I will let you know that, hey, let's go and knock out some more questions. But I'm pretty sure if I'm going to do 15 questions, I'm going to try to do this in the next 20, 25 minutes. I'll be pretty tired at the end, and I'm not sure if I'll be able to add in anymore. So hopefully polynomials algebra, that's one question is good. I haven't seen back from you, so I do appreciate, again, the super chats. So I put you up there. And you know what? Just for that, let's add that in there. I don't think I've seen anything else from you. Boom. So let's go and do that one first, actually, since it was at least super chat. So if we need to, he was asking for factoring polynomials. All right. So here's a quadratic. This was given to me. One of the best ways when we're dealing with a polynomial raised to the fourth power is when it's a trinomial, we want to factor via how we factor trinomials. So a lot of times what I have to look at is, remember back in the day, algebra 1, algebra 2, we factored a polynomial like this, minus 5x squared minus 36, right? Oops, 5x. So this was a quadratic trinomial. And one of the things we practiced when we were factored a quadratic trinomial is that it was going to be factored down into a product of two binomials. So we could say product of two binomials. And basically what we're looking into, there's a lot of different ways to do factoring, or at least to teach factoring. But one of the ideas, at least that I kind of do it, or I look at it now, is we understand that when we're going to factoring is writing a polynomial as a product of two factors. So in this case, we're looking to what two binomials are going to multiply to give us this whole expression. Well, to get our first two terms, we know that this is going to have to be x and x, because x times x, right? When we do FOIL, x times x gives us x squared. And now we basically want to look at, well, what two numbers are going to give us negative 36? Now, there's actually a lot of numbers that multiply to give us negative 36. So you could list them out. Hopefully, we'll want to kind of get really good at this and understand that we're looking for ones that are going to give us a difference of negative 5. So what I'm going to do is I'm just going to list out the factors of 36. Let's do this slowly, I guess. And this would be 2 times 18. Let's see, this would be 3 goes into there 12 times. And again, I'm looking for a difference. Since this is a negative 36, one of these is positive and one of these factors is going to be negative. So therefore, my negative, I'm looking for a difference of these two factors to be negative 5. So that doesn't happen. So then I go 4 and 9, and voila, these have a difference of 5. So since 5 is negative, that means the larger of the two factors needs to be negative. So therefore, I'll make this a 9, and this is going to be a positive 4. So again, 4 times negative 9 is negative 36, and then my inner and my outer add to give me a negative 9. So that's why you can always check your work. Now, that was for quadratics. So this is the same thing. Notice everything's exactly the same. The only difference is the degrees are now higher, right? So therefore, we can just rewrite this. We know that the numbers are going to be the same, right? We still have negative 5, negative 36, and an x, so that's not changing. The only thing that's changing now is our powers. So now we can raise these to x squared plus 4 and x squared minus 9. Now, one of the things is, depending on, in this class, depending on your class, you could break this further down. So if we wanted to break these across rational numbers, we could factor down x squared minus 9 2x minus 3 times x plus 3. And if we wanted to factor across complex numbers, we could also factor that into x plus 2i times x minus 2i. We don't really do that for factoring practice. We do this when we talk about the zeros of a polynomial, you know, finding like the complex solutions and all that kind of stuff. But either way, that is just a way to factor down. Typically, we're either, depending on the question, you're going to be looking for one of those two types of answers. All right. Let's go back up now to the beginning. I can already feel my voice is starting to go. All right, so given a root -1 is a root of x cubed plus 3x squared minus x plus 1, find the remaining. So when doing synthetic division, one way you could do synthetic division or long division. Whenever our root is just a number, or like our 0 is just a number, typically I just like to use synthetic division. So what you're going to do for synthetic division, you're going to take that root on the outside of this nice little kind of diagram, and then you're going to take the coefficients of your polynomial. So 1, 3, -1, and 1. Now, when doing synthetic division, you want to make sure that if there is not a variable like an x squared or an x, that you use that place value of 0. So I bring down the 1. 1 times -1 is -1. 3 plus -1 is 2. 2 times -1 is going to be a -2. Uh-oh, something's not right. Dang it, did I make up this problem wrong? 2, that's -2. That becomes a -3. Dang it. I did mess up the problem. All right, so hold on, I made up this problem. 3x plus 2, and this would have been no, that was supposed to be a x plus 2 times an x plus 1, and this is supposed to be an x minus 1. So 2, 3x, that's right. Okay, sorry guys, this is why I ask people to give me questions. So therefore I make sure that I don't make mistakes. 3x plus 3x squared plus 2x minus x squared minus 3x minus 1. So x squared, that's a 2x squared. 2x squared minus x minus 1. Okay, so sorry about that. Let's try this again. So you still could have done division, but if you did division, then you can notice I would have had a remainder. And the problem with that is there's nothing wrong when you're using division for there to be a remainder, but that means that that is not a 0, so it wouldn't work. All right, so 1, 2, -1, and 1. Let's try this again. So I bring down the 1. 1 times -2 is -1. 2 plus -1 is 1. 1 times -1 is -1. This becomes a -2. Oh my God. What is going on? Oh. This is embarrassing. This is why. What did I do? I am not getting this. Times x minus 1. That becomes a x cubed plus 3x squared plus 2x minus x squared minus 3x minus 2. That's an x cubed plus, that's a 2x squared minus x, minus 2. I'm an idiot. Gotta go slow. There we go. Remainder of 0. Perfect. Okay. So anyways, do the division. And again, if you don't get a 0 here, remember that's the remainder. That's why I knew there was a mistake. And again, I made up this problem. That's why I asked you guys not to make me make up problems, because I'm going to make a mistake, right? So give me some problems that you're working on, or at least something that is from a book or something that that you want me to discuss. Now again, this means that's divides, but again, we got to further understand what this is. So this is your remainder, constant, coefficient of your linear, coefficient of your quadratic. So this divides into this. That gives us a quotient here of x squared plus x minus 2. So this is a factor. And if we want to find the roots, then we just need to further factor this down. So what we can do is take this quotient equal to 0, and now to go and solve. So hopefully if it's factorable, we can just factor it. If it's not factorable, we want to use the quadratic formula. There's obviously larger problems where we would have to do synthetic division more, but that's if we were given more roots. I'm just doing a basic example. And this one I recognize to be x Let's see, plus 2 times x minus 1 equals 0. So therefore that gives us a root of negative 2 and x equals 1. So therefore all the roots here are, I'm going to use a set notation actually, negative 2 and 1 and negative 1. And notice there's 3 roots and the degree is 3. Interesting, something we talk about. All right, solving a systems of equations. If I was given something like this, they didn't tell me how to solve it. So I am assuming that they want to do the fastest and easiest way. Since I already have y is equal to 3x plus 4, I am going to use substitution. So all I'm simply going to do is replace y with what y is equal to, which is 3x plus 4. And I'm going to use parentheses to represent I am replacing y with 3x plus 4. Now I can just simplify. That becomes a 6x plus 4 equals negative 4. Subtract a 4. 6x equals negative 8. Divide by 6, divide by 6. X equals, you can divide by 2 on top and bottom, a negative 4/3. So again, that's what x equals. But again, we want to look for what the x and the y. So the solution to a system is the x and the y coordinate. So therefore, now I'm going to substitute x in for the value, negative 4/3 plus 4. So therefore, that's a negative 4 plus 4, which y is equal to 0. So therefore, if you were to graph this, you would have a solution point of negative 4/3, 0. But it looks like substitution is going to be the easiest method in this case. For those of you that are kind of adding on, I'm not going to be able to get into any more of the questions kind of being submitted. Right now, I already have 15 of them. And you can kind of maybe scroll back to see when I kind of scroll through those questions to determine if there's any of them that I'm going to do that will help you out. So I'll probably take a break here at 5:10, and just to kind of give myself a little bit of just a little quick break. All right, solving this. Solving this problem, so I completely made this one up. Hopefully, I'm not going to be able to solve it. Well, actually, I will, but I don't know, I made it up, so hopefully it's a good equation. But the student asked for ones with a different exponent, so I'll just pick this one. But the main thing is when we're solving this, I don't have a calculator, so I'm not going to be using logarithms. So what I'm going to want to use is the one-to-one property. So, the one-to-one property is pretty kind of obvious. If I say 2 to the x is equal to 2 to the 4th, it makes sense then that x has to equal 4, right? When we have exponents with the same bases, we know that the exponents are going to be equal to each other. Now, the problem here is these aren't the same bases, but I can rewrite 8 as 2 to the 3rd power. Right? There's nothing wrong with rewriting 8 as 2 cubed. And then using the rules of exponents, remember when you have an exponent raised to another power, right, or you have this power multiply, then, actually, I'm sorry, this is just not raised to the power, but yeah, you have this 2/3 raised to the power, you're just going to multiply these. So this is going to be 2 to the 3 times x plus 3. Just make sure you put parentheses on there because you need to distribute that. Now you can see my bases can be dropped off. So therefore I have x equals 3x plus 3. And now I'll just subtract a 3x on both sides. Negative 2x equals positive 3. Divide by negative 2. X equals a negative 3/2. And there you go. That is your solution. So another thing you could also do is look into taking the logarithms. Obviously, when you want to get your same bases and then take the logarithm of whatever that base is to eliminate that if you can't use the one-to-one property. The next one is condensing. So again, condensing, what we're trying to do is a couple things to remember. We're trying to write this as one single logarithm. So we're going to want to follow the rules of logarithms. Remember, typically you always want to work from left to right. So in this case, I am going to condense these two logarithms. Well, condensing these two logarithms via the rules of logarithms is going to give me a plus b squared times a minus b squared minus ln of a squared minus b squared. Now, using the rules of logarithms, if I'm going to subtract these, then I can rewrite that as a division. So that's going to be ln of a plus b squared times a minus b squared all over a squared minus b squared. Okay, now just remember a squared minus b squared is the difference of two squares. So that can be written as a minus b times a plus b. And then notice how each one of these is really, let's actually just expand everything out. So this could also be written as a plus b times a plus b times a minus b times a minus b all over a minus b times a plus b. So by multiplying or expanding all this out, you notice that, oh, well, these a minus b's can divide out and these a plus b's can divide out, leaving me with just, put some equations here, ln of a plus b times a minus b, or ln of a squared minus b squared. So that is just a way to go through that. As far as the bearings go, so I got another question that came in. I'm not going to be able to solve it, but I'll at least kind of get you set up. The main difference with bearings, when we did standard form, here was standard form. Standard form started here. So when you're doing the bearing, you're starting from due north. Basically, we'll call our cardinal directions: north, east, south, west. All right. So if I say they had a bearing of 17 degrees, so that's going to be from due north. Now 17 degrees is going to be clockwise, so positive is going to be clockwise. So the graph would look something like that. Okay, and then you could say, from port is still going to be at the origin. And then at 5 miles, the boat turns at a bearing of south 50 degrees east. So when you have something like this, my goal before they gave me the question was to, typically you're either going to have bearings in terms of like degrees, which is always starting due north, and then clockwise is considered positive. And whereas standard form, that's 17 degrees in standard form. So in bearings, that's 17 degrees in bearing form. If they give you something as a cardinal direction, then you're going to start at south and then 50 degrees east. So you start south and then you go 50 degrees east. So then my angle would look something like that. Okay? All right, so this student has a similar kind of question. They actually, though, want to find the bearing. So unfortunately, you're going to have to do a little bit more advanced math. I just wanted to show students how to graph this. So you're going to do north 20 degrees east. So we're going to do due north, right? And then 20 degrees east. Oh, crap. And then they want to do north 40 degrees east. Okay, so let's not go that far. Actually, I got an idea. Just move this over. Give myself a little more room. All right, so we're going to do north 20 degrees east. So let's say it's something like this. And let's say that's 20 degrees, right? Then they pivot, right? And now they're going north 40 degrees east. And let's just kind of do something a little bit more. So again, like you can say from due north, right? There's due north and there's due east. Now they're going 40 degrees north, 40 degrees east. And they're doing that for, so like this distance is 300 miles. So either way, let me change my angle here or my colors. So they go this far, right? And then the question is like, what is their bearing? So basically what we have is we have an oblique triangle. So we have this triangle, which is 300, and then we have this, and then we have that. So what we need to basically figure out is like, what is that angle? So we know that this is going to be 20 degrees, right? We need to basically figure out what that angle is going to be. So there's a couple different ways on doing this. What I would basically do is we know that's 300, that's 150 degrees. We can basically either use the law of sines to find this angle. And once you know this angle, then you could use the law of sines or the law of cosines to figure out the remaining ones. But the main idea is once you figure out the angles or enough information using the law of sines or the law of cosines, then you just basically are measuring from due north over, like how far you're at. And again, it's going to be whatever this angle is. Let's solve theta. So I'll just give you so the bearing is going to be theta plus 20 degrees. But you're going to have to figure out what theta is using the law of sines or law of cosines. Draw a triangle, and based on you have two side lengths, and actually you don't have that angle. So what else could you do? Oh, you have that angle. That's underneath 50 degrees. I'd have to look at my quadrant thing, but there seems to be enough information to be able to solve this. Just be able to you look at geometry, look at your angle measurements to be able to help you with that one. And but there should be enough to be able to figure that one out. I just don't. It's a good, but it's a long problem, which for the live stream I'm just not going to have time to kind of further go through. But hopefully, at least the setup process helped you out a little bit. All right. Yes, and sorry guys, I am going to. Oh, so that was question number 5. So I'm just going to take a quick little break. I'll get to 6, 7, 8. 9 and 10, and then I'll just do another quick little break before we finish off the last 5. So hopefully I'll be trying to get done here before 10 o'clock. So good to see Michael, Muhammad, Pori, Anthony, Tiana's Lover, Neptune, Fire Street, Grace. Thank you guys for joining in. Oh, man, this is a lot of good old questions, and I'm sorry guys I see a lot of you guys asking some questions. Hopefully you guys I see a lot of you guys are helping out in the chat, so thank you so much for being able to get to things, because I'm just not going to be able to get to the questions for this live stream. So I really do appreciate those of you that kind of know what you're doing, that can help others that are trying to ask some questions, because I'm just not going to be able to get to them tonight. And I know a lot of people are very stressed out. You got a lot going on with the exam, so I am going to still be covering some questions here, and hopefully I can get to them in a quick time frame here. All right, so let's go ahead and get back to it. So evaluate. So basically we're just looking for our two angles that we can add here. Well, that's going to be the tangent of, let's see, that's going to be negative 60 degrees plus negative 45 degrees. Now it doesn't matter which angle you use first. Okay, but you can see that I'm adding negative 60 degrees plus negative 45 degrees gives me a negative 105 degrees, right? So now we're just going to call this A and this B and then plug them in. So so that's going to equal, let's see, the tangent of negative 60 degrees, I'm going to use parentheses here, plus the tangent of negative 45 degrees, all over 1 minus the tangent of negative 60 degrees times the tangent of negative 45 degrees. All right, so depending on what your teacher or the problem is asking you to how to simplify, I'm just going to go through the unit circle, just knowing my basic understanding of the unit circle. So tangent, this is going to be an angle in the 4th quadrant, which is going to be negative square root of 3. Plus, this is going to be in the 4th quadrant, so that's going to be negative 1. All over 1 minus negative square root of 3 times negative 1. And from this point, I'm just going to kind of get rid of these negatives here. So it's going to be negative square root of 3 minus 1. All over, that turns into a positive, but that's a negative, so that's going to be 1 minus the square root of 3. That's typically the answer. However, sometimes we'll be asked to go ahead and rationalize the denominator, so I can multiply by 1 plus the square root of 3 times 1 plus the square root of 3. Sometimes it's also maybe preferred to rewrite this as a negative 1 times square root of 3, which that's what I'm going to kind of do. So therefore my answer here up top is going to be a negative 1. Let's go and see. That's going to be a negative 2 square root of 3. And this would be a negative 3. Right? Negative square root of 3 times positive square root of 3 is 3. And that turns into a negative. This is a difference of 2 squares, which would be 1 times 1 is 1. And then that's a minus 3. All right. So kind of running out of space here. So negative 1 minus 3. So let's do this. This is horrible. I hate when students do this, but I'm going to do it. So negative 1 plus 3 is a negative 4 minus 2 square root of 3 divided by negative 2. and then I can divide this in. So I have a positive 2 plus the square root of 3. And I hope I didn't make a mistake there. These problems stink because they're so easy to make mistakes, either via the unit circle or either be by the unit circle or just, making a negative error. So hopefully I didn't make a mistake, but that would at least be the process from there. And if I did, I apologize. It's, these mental errors stink. All right, let's go with the graph. So we have graph y equals 2 cosine of 3 theta and graph y equals 2 cotangent of 3 theta. So for cosine, remember when we have this 2, this is the amplitude, right? So the amplitude is going to equal 2. That's basically how high the low in graph goes. Technically, the definition, though, is the half distance from the max to the min, because only cosine and sine have an amplitude. The next thing is we have our 3 theta. Well, that is going to change our period. That is our b. So instead of the graph repeating every 2 pi, now the graph is going to repeat every 2 pi divided by 3. The last thing you want to do for when you're graphing is to identify the x scale. And basically for the x scale, all you're going to do is take 2 pi divided by 3 and then divide it by 4. So if I was going to divide this by 4, that's the same thing as multiplying by 1/4. So that's a 2 pi over 12, which is pi over 6. Okay, so I'm just going to, all right, I'm not going to be able to get to cotangent. You know what I'll do? I'll do tangent down here. I'll do the tangent. So let me go ahead and graph the cosine just so I can kind of show this. And then I'll do the cotangent on the other one. So for this case, I'll do cotangent later down here. Actually, somebody asked me to graph cotangent. So sorry, I'm just not going to do this one. I'll do the other one for tangent. Because I was just making that up. Someone asked for tangent, cotangent, but then someone did a tangent. So I'll show you the examples. All right, so let's talk about the initial period. So this is what we call like the parent graph or the initial period. So the initial period, the graph goes up to 1, down to -1, and then repeats every 2 pi. So there's pi, and then, let's see, that's at pi halves from there. Okay, so that is what cosine, that is y equals cosine of x looks like. Now, our graph, the last couple things is, well, we don't know if our graph starts at 0 and ends at 2 pi. So what we're going to do, though, is we're going to take whatever's inside the function, which we call the start, and we're going to set that equal to 0. And that's going to give us our new start point. Well, in this case, it's going to start at 0. And then we're going to set it equal to 2 pi. So that's going to be our end. And so therefore, we take 3 theta equals 2 pi. And you can see that theta equals 2 pi over 3. So I'm just going to do one initial period. You can continue on if you need to. But 0 equals, and then let's just do 2 pi over 3. All right, now the graph, instead of going up to 1 to -1, it got stretched, right? It vertically stretched. So now the graph is going to go up to 2 and down to -2. The x scale is the important point. So notice how there's 4 points. This is pi halves and this is 3 pi halves, right? So 1, 2, 3, 4. So I'm just going to do the same thing. 1, 2, 3, 4. So the distance between each one of these is what is our x scale. So I'm just going to do this as pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6. So I'm just adding pi over 6, which is 3 pi over 6, which is pi halves. And then 4 pi over 6. That looks horrible. 4 pi over 6, which is the same thing as 2 pi over 3. So my graph, remember, goes down to here, and that's really it. So now I'm just going to do the same graph. It's going to cross here, there's there, crosses there, and up's there. And then if you want to continue doing that, graphing that, then you could just continue adding your x scales. So I don't really like graphing. I don't teach it anymore because that x scale part is difficult, but basically all you're doing is taking the period, dividing it by 4, and then you want to find the new start and the new end. So basically you set whatever's inside your function equal to 0, that's the new start, and then you set whatever's inside your function equal to 2 pi, and that is your new end. And again, this is just one initial period, but I think the most important thing is knowing what the initial period looks like, and then just being able to identify all the different characteristics. So, The next one, graph y equals 1/2 x minus 1. So to do this, we need to know how to graph y equals the line y hat 1/2 x minus 1. Y equals 1/2 x minus 1. That is just going to be a line. Remember, using slope-intercept form, y equals mx plus b. Okay, so again, remember b is your y-intercept, so that's going to be on the y-axis. You're going to go down to -1. M represents your slope, which is the change in the y-coordinates over the change in the x-coordinates. So that's going to be up 1 over 2. So that is the linear equation, or y equals 1/2 x minus 1. So the only difference for the inequality is, remember, when it's less than or greater than, it's going to be the same line, but it's going to be a dashed line because the line is actually not included in the solution. So I'm going to graph the same line, but now I'm going to use a dashed line. Now the important thing is, the points that made this equation true, or the points that make this equation true, are all the points that lie on the line. However, inequality just says that the points that are going to make this inequality true cannot lie on the line because the line is not a part of the solution set. So what we need to do is we need to represent, there's actually infinite many solutions that can make this inequality true. So what we need to do is pick a test point. Now the best test point to pick is 0, 0, unless your, what we call our test line, goes through that point. So as long as it doesn't go through a point, use 0, 0. But otherwise, try to use a point where it's like 0, 1 or 1, 0, right? Or, use one of those 2 points because you can't go through all 3 of them. So so what we usually do is just say test, and then we'd say what our test point is. And then all you're going to plug it in is 0 is less than 1/2 times 0 minus 1. 0 is less than -1. Now that is false. So that means this point does not make this inequality true. And guess what? It doesn't matter what point I pick. I could have picked any one of these points. They all would have been false. So that's why we just want to pick the one that's going to be algebraically the easiest. So all these points are false. So therefore, if we want to represent the true solutions, right, then we're going to pick the points on the other side. And a lot of times we'll just do like some dashed lines there. All right. Let's get into tangent for graphing tangent, and then I'll do an expansion here. So when we're graphing tangent, it's a little bit different than sine and cosine. Tangent does not have an amplitude, but we see there is a reflection about the y-axis. So we see reflect y-axis. There is no amplitude of 2, but you can see that the graph is being vertically stretched by a factor of 2. So I can just say vertical stretch of 2. And we have a vertical translation going down 1. Now, there's really nothing horizontally that's happening to this graph, because if there was, it'd be inside of the tangent function. So there's literally nothing that's moving the graph left to right. So that's why it's so important to know what the parent graph looks like, or the initial period. So typically in your notes, the initial period is going to have an asymptote at -π/2, another asymptote at π/2. And the graph looks like this nice little S-curve like that. Now again, remember, nothing is horizontally happening. So therefore, these asymptotes are going to remain the same, okay? But to graph it, let's pretend this one's a little bit easier. So let's go ahead and do 2 periods in this case. So again, you want to use the x scale. You want to identify the x scale. And you do the exact same thing as far as the start and the end. For tangent, though, you would do the start is from your initial period. So the initial period starts at -π/2. So I would set whatever's inside my function equal to -π/2. And for the end, I would set the end of the initial period is at π/2. So I'd set whatever's inside my function to +π/2. So you can see how that's kind of different. You can see how that's kind of different from -π/2 to +π/2. But again, there's no horizontal transformations in this example. So we don't need to worry about that. The x scale is something that I would confuse my students with a lot too, because there's really only like one major point here. Like we have asymptote. So from the start, we have intercept, and then asymptote. So my x scale, what I like to do is take the period divided by 2. So that's different than over here, where I took the period divided by 4. And a lot of students would get that confused. And then eventually I just said, you know what? I'm done with this. It's not that big of a deal. And so that's why I don't really cover it as much. But in reality, you need to understand the transformations. The period is pi divided by b, Remember that. So nothing's really changing here because we don't have a B or a C, but those are some things, case in there. All right, so if my period is pi divided by 2, so I have a asymptote here at negative pi halves. Here's 0. Pi halves. Well, if I add pi again, that's going to take me to pi. If I add pi again, that's going to take me to a 3 pi halves. Now again, remember this graph, and I'm sorry, not everything's perfectly to scale, but it looks like this, but again, it's being stretched, but also it's being shifted down one. So instead of the y-intercepts being here, they're probably going to be shifted down a little bit, and we're going to have kind of maybe a little skinnier of an S-curve. And that's it. That's really kind of the difference. I mean, obviously you could plug in more points if you want something a little more detailed, but again, graphing is not that big of a portion in my class. So I would like to rely on graphing technology. All right, so we did a condensing problem. Let's do an expansion problem. So when we're expanding a logarithm, again, this is all just rules of logarithms. So the first thing we want to do is take whatever powers we have and put those down in front. And if you remember previously, we took the difference of two logarithms and we wrote them as a division, or I'm sorry, as a quotient. Well, now if we have the logarithm of a quotient, we can rewrite that. Just make sure you use brackets here as the ln of quantity. And sometimes it's important to put those in parentheses so we remember they're together, to the ln of ln times the quantity e plus 1. And it's very important to use these parentheses because you're not taking the 2/3 of just this first ln. It's to both of them. So notice my use of parentheses that I use to make sure we understand that, because a lot of students would not insert the parentheses and it would be wrong. The next one is evaluate. So again, using rules of logarithms. So there's a couple different ways we could do this. We obviously know that the log of b to the b is just equal to 1. Or you could say log base b of b to the a is equal to a, right? So these are two logarithms. I'm using a's and b's. But this is important because in this case, I have the base of the same argument plus 1/2 times log to the base. And then you really could write 4 as 2 squared. So we can use both of these rules of logarithms here. So this is 3 times log base 2 of 2, which is just going to be 1, plus 1/2 times log base 2 of, well, again, that goes to just your power, which is 2. So 3 times 1 is going to be 3 plus 1, which is equal to 4. And there you go. All right, the next one, secant. Now, I didn't cover this with my students as far as the inverses of secants, just because we're going to get into that next chapter, and I just wanted to kind of simplify things. But I'll kind of cover for you guys. So the main thing is, a couple ideas here. We know that secant inverse of square root of 2 is equal to an angle. We don't know what the angle is, for at least right now, but we know it's equal to that angle. So therefore, again, we can rewrite this statement as secant of some angle equals the square root of 2. That's what the inverse represents. That's what I'm asking. When I say the secant inverse of square root of 2, I'm asking the secant of what is equal to the square root of 2? Like the secant of what angle is equal to the square root of 2? So I can take this equation and rewrite it like this. Well, again, I'm not as well versed with the unit circle for secant, so why don't I rewrite it as the reciprocal? Now that's a little bit more familiar for me because remember that secant and cosine are just reciprocals of each other, right? Secant is 1 over x, cosine is x. So they just reciprocate. You just flip them. So now I can say, oh, well, the cosine theta of square root of 2 over 2 is really the same thing as me saying cosine inverse of square root of 2 over 2 using those restrictions is going to be pi over 4. So I'm using the reciprocal relationship to go ahead and evaluate. So now I have cosecant of pi over 4. Now again, remember the cosecant is going to be 1 over y. At pi over 4, remember guys, it's x over y. I'm sorry, it's square root of 2 over 2, comma square root of 2 over 2. So this answer is just going to be square root of 2. All right, so guys, we only got 2 more questions left. Awesome. Thank you guys so much for joining, right? Edward, Anthony, Neptune, good to see you guys on. Man, you guys getting a lot of chat. That's awesome. Good for you. Good thing is going through. Good conversation. Can you find the slope and y-intercept? Yeah, set the equations. I'm liking it. All right. All right, I got 2 more questions. Let's go to this, and then I'll kind of see. Yeah, I said 10 o'clock, so we're getting to that end. But either way, let's go ahead and work through this. So finding the main thing, guys, when you're identifying holes in asymptotes, you got to simplify it. I went through a problem today where a student, we were doing like review problems because I give them review problems, every homework, and they just divided out the x squareds. I'm like, no, we cannot be making these mistakes anymore. When you have these binomials, think factoring. And I know many of you just want to avoid factoring, but it's a very, very, very important skill, especially in our math, to make sure that you can simplify these problems. Because by simplifying by factoring, that allows me to break this problem down to look at it in a different way. And when I can look at this problem as a product of its factors, now I have terms separated by multiplication. Now I can apply the division property. You can't apply the division property when you have terms separated by addition and subtraction. But now that you have things separated by multiplication, you can. So now I'm left with x minus 2 over x plus 1. But again, we have to remember that there's 2 values that are what we call our discontinuities. So, x cannot equal negative 2. That is not a discontinuity. It is a discontinuity, but it is I was trying to think of an excluded value. That's something we talked about. And x cannot equal negative 1. But these are both discontinuities, but how are they different, right? Well, x equals negative 2. The reason why that x cannot equal negative 2, because in the original problem, when you plug in negative 2, that makes the denominator equal to 0, right? However, by factoring it, I was able to simplify that out or divide that out or remove the factor. So therefore, it is not only called a removable discontinuity, but we also call it a hole. The other discontinuity, the other number that's going to make our function -0 in the denominator is negative 1. And if you were to take negative 1, plug it into your denominator, you're going to get 0 in the denominator. Or go back to the original problem. But notice, negative 1 never got removed, right? It's non-removable. And a non-removable discontinuity, in our case, is going to be an asymptote. And there you go. All right, last question is finding the left and right hand behavior. So left and right hand behavior is just another way of looking at the end behavior. Now, there's really, I'm going to look at the odd. There's only 4 end behaviors, right? You can have something that's going to go up and up, down and down, up and down, and down and up. Like, that's it. That's the only behaviors you got. Like, as a graph expands left and right and up and down, that's all you got. So notice that these kind of look like cubics and these look like parabolas, right? And so how do you understand what the behavior is? Not by knowing the graph, but by actually looking at the equation. So what we're going to compare is our degree. No. Yes. Yes. And our leading coefficient. That's it. I wrote those different. So let me do these. This is not how I like to do mine. Okay, let's do it like this. There we go. Let's flip these. I always draw my diagram the same way, but I decided to do this one differently. Okay, so if I'm going to be doing my degree, so again, if my degree is even, the graph is going to go up and up or down and down. Or if my graph is odd, you can see they're going to go in opposite directions. That is going to be the end behavior, and there's no other options, right? Like, it's either up and up or down and up, right? Or down and down or up and down. Like, that's it. So how do we determine which one is which? Well, it depends on the leading coefficient, right? So which is the coefficient of your degree. So that is going to be, so they're either going to be positive or negative. So when it's positive, it's up and up, or falls left, rises right. When it's negative, it's going to be falls left, falls right, or rises left, falls right. And there's obviously different notation. You can use limits, and we go through a whole bunch of stuff in my class as well. But the main idea is you want to identify what is the leading coefficient. And so our leading term is going to be the term with the highest power. So all we're going to look at is -5x to the 4th. it doesn't matter what else we have here. We really actually don't care about that. We only care about our degree. And our leading coefficient. And here you can see our degree is even, so it's going to be one of these two. And our leading coefficient is negative, so it's going to be this one. So we can say our is going to be down left and down right. And again, there's other ways to write this that are more mathematical, but hopefully that at least just kind of gives you an idea of how to determine that. All right, guys, I am done. I hope you guys found some bonus for the bonus live stream, and this helps you out. And appreciate it. It goes, Brian, you have truly helped me through my math. I'm so thankful. Thank you very much, Julia. This is Julia. That is very, very nice of you. I'm very happy to be able to help you guys out. Malin as well. Thank you, Nate. That is very great to hear, guys. And you know, a lot of you guys adding into those comments or obviously joining me onto the live stream. You know, that's the reason why I enjoy being able to do these live streams, is to interact with you guys, help you out. Obviously, I don't have the time to get to all the comments on my videos anymore like I used to. It was such the good days when I just used to respond to all the comments. For those of you that are joining, onto the live stream, obviously I don't have time to be answering a lot of your questions, but however, if you always do want to, want to see if there's a comment that I'm going to be able to read on my community tab. At this point, I read all the comments that come into that community tab prior to my live streams. I try to get back to some of the old ones, but I always recommend going to those my most recent community tab. I'm always responding to those up to my live streams, and then also when I add a new video, usually for that first 2 to 3 days before I go another upload, I am always looking into the comments and trying to answer those questions. So I know I see a lot of people still responding to a lot of comments on my old videos, which I love and appreciate, and I wish I had more time to read all of them and respond to them. I just unfortunately kind of get locked in time with that. But all right, guys, otherwise I have to go. This was an hour live stream, and I wasn't really expecting it to go that long, but I have school tomorrow, which I hope that none of you guys do, but any of you already took your exams. But if you do, I wish you the very best. And then also remember, I will have another open Q&A this Sunday at 9 p.m. on my regular time. So if you do have some more questions, and hopefully I can get to you before your exam next week, if that's when you have it. So just make sure you leave a comment down below, and I look forward to seeing you guys on the next live stream. All right, cheers.